Hello, my dear students. If you remember, we spoke about this little effect called photoelectric effect. Yes, when the light of suitable frequency incident on a metal surface, the electrons are emitted by the metal. This phenomena is called as photoelectric effect. Diagram over here is showing the photoelectric effect, where the metal is kept over there and the UV radiation is incident on it. So the electrons are ejecting. This effect created the curiosity among the scientist community because of the weird observation, and many of the scientists came forward with their observation. The German physicist William Holwich, he found that the metal plate irradiated with the ultraviolet radiation lost its charges more rapidly when the plate is negatively charged than the neutral or the positively charged. Then the physicist called Philip Leonard came forward with his observation. He observed that electron emission occurred only when the radiation below critical wavelength, that is above the critical frequency. The kinetic energy of emitted electron increased as the wavelength decreases, that is, frequency increases, but independent of the intensity of radiation, which determines the rate of emission of electrons. In order to understand his observation, you first have to understand the relation between the frequency and the wavelength. Both are in inverse proportion to each other. When the frequency means lambda, frequency means nu, and the wavelength means lambda. If your lambda is increasing, then frequency will be decreasing, and wavelength is decreasing, then the frequency is increasing. Means the electron emission occur only when the frequency is above the critical or the wavelength is below the critical. So after Philip, the Heinrich Hertz came forward in 1887, and we are going to study his observation in detail. He observed that the spark gap conducts electricity more easily when it is illuminated by UV light or the ultraviolet radiation. The first systematic study was done by him. So we will see his experimental setup. His experimental setup involves the vacuum. His setup involves the vacuum chamber with a metal plate inside and an opening for a light to shine on the metal plate. So to the collector, collect the electron and measure the properties. And to measure the properties of this electron, there is a collector plate kept near, which is connected to the external circuit. When these electron hits the collector plate, current is induced in this circuit, and thus current is measured by microammeter. This current is also called as photocurrent. They also wanted to see how this photocurrent vary with the frequency and intensity of incident light falling on the plate by using different color filters at the quartz window through which the light is passing directly to the photosensitive collector plate. To vary the potential between the emitter and the collector, and there is a potential dividing arrangement which is followed by the commutator key and the potential dividing arrangement. This addition we will see afterward, but the observation they make would change the course of scientific history altogether. Now we have this setup Let's go back to 1902 and put ourselves in their shoes to explore the effect, as they believe that light is electromagnetic wave. To understand this effect, we have a simulation of this photoelectric effect. Experimental setup of photoelectric effect. If the question asks about this, then you can write some points. And this is the diagram which is from your textbook. The first point is it is consists of the evacuated glass tube with a quartz window. The metal plate C is fixed in front of the window and act as an emitter. The metal plate A act as a collector. The collector is connected to the positive terminal of the battery and the emitter is connected to the negative terminal of the battery. The potential between the emitter and the collector is maintained by potential dividing arrangement. The potential between C and the emitter A is measured by voltmeter. The photoelectric current is measured through this microammeter. So in order to understand this experiment and its observation, we have one beautiful simulation of the photoelectric effect, which is something like this. It is a bit different from their textbook picture, but it is similar. Okay, here is the evacuated glass tube and an emitter plate which is connected to the wire. In front of this emitter plate there is one more plate which is collector plate. Both are connected to the wire with a battery, and initially the potential bit provided by the battery is at 0. There are two knobs, one is for intensity and one is for the frequency. When we increase the intensity of light source increases, and we can vary the frequency of the incident radiation. As you see, when the intensity is at a particular value and we are just changing the frequency of incident radiation, so the photoelectrons are emitting from the emitter plate and they are get collected to the collector plate. Was your photoelectric effect, its experimental setup and the working. In the next video, we will see the detailed observation of the photoelectric effect. So our next video on physics measure will be on the observation of the photoelectric effect and the threshold frequency. Do subscribe to our channel, hit the bell icon and share with your friends and family.